let's take a look at this one. And the first thing I notice is that this one is division. It's not multiplication. So we're going to have to do that thing where we keep it, change it, flip it, right? Okay, so let's put it in mathematical terms. We're going to multiply by the reciprocal. So I'm going to keep this. Don't change it. Don't be like, oh, division, I got to flip the first. No. It stays the same. I'll tell you why in a few minutes. Division becomes multiplication if we flip that over and reciprocate it. Well, I said I'd show you in a few minutes. I'm going to show you right now. Very quickly, let me show you what this means. If I did 6 divided by 2, I mean, I know what that is, and you know what that is, right? I mean, there's no secret, that's 3. It's the same idea. Keep it, change it, flip it. Well, this is 2 over 1. Let's make it 1 over 2. What's 6 times a half? In other words, what's half of 6? 3. Same idea. So this is kind of a more concrete idea about why we do this, about the keep it, change it, flip it. I just wanted to show you why we do what we do. Okay, so you're probably like, well, you flipped it over, now what? Well, let's start factoring. Maybe some stuff will factor. So I'm going to come down here one more step and factor this. So does 8 factor? Well, yeah, it's 2 times 2 times 2. And you can put that if you want to. I actually am, for the sake of explanation. So 2 times 2 times 2. Okay, put that or not. X minus 12, does that factor? Oh, no, and now don't look at this and say, well, 12 is 2 times 2 times 3. This is all like one quantity, so keep it. And if this 2 times 2 times 2 is throwing you off, don't panic. You'll see where it's going in a minute. All right, X minus 11, well, that doesn't factor. Put it in parentheses if you want to. Is there a greatest common factor here? Yeah, I'm looking for a GCF. 6 goes into 6, obviously. 6 goes into 66. And so I'm going to put a 6 in the front, and then X minus 11, 66 divided by 6 goes there. Now, this is not wrong. It's perfectly fine. You don't have to change a thing. But because I'm the one explaining this, I'm going to change this 6 to a 2 times 3. And in just a second, we'll see some things that cancel out. So let's grab the orange marker that you can barely see the ink on, and let's start canceling. Let me go for the obvious. You see it, right? Okay, cool. Anything else cancel? Now, let me warn you, you can't reach in here and do anything with this 12, because this 12 is all part of one factor, but we can cancel some other stuff. We can cancel a 2 with a 2, okay? So the numerator ends up being 2 times 2, so 4. The denominator ends up being x minus 12 times 3. I'm going to put the 3 in the front. And if you did not put 2 times 2 times 2 here, you'd still have 8 over 6, and 8 over 6 still reduces to be 4/3. So we still get the same thing, you'll just need to reduce it a little bit more. So sometimes you may want to do that step just to know what you need to reduce later. Not absolutely necessary, but this is the final answer. If you put 8 over 6, it's technically wrong because you've not reduced it completely. So all of these, you're just trying to simplify as much as you can, and that means reducing it. Let's do a couple more. I'm going to switch colors here, no reason. Z squared, it's a good variable. Z squared plus 18z plus 80 divided by z plus 10 multiplied by, okay, immediately when I write multiply, you know what you don't have to do. You don't have to do keep it, change it, flip it. Keep it, keep it, keep it, keep it, keep. When you multiply, just keep it. It's fine. 2z plus, what, 16? Yeah. I said that like I was asking my paper. Is it plus 16? Yes, it is. Okay. So again, keep it, keep it, keep it. If this was division, we'd keep it, change it, flip it. We're not. Let's start factoring. Looking for a GCF. Do I see a GCF here? Z squared, 18z, and 80. No. Yeah, there's some stuff here between these two and stuff with these, but generally no, not for all three. So this one actually factors. Not every trinomial factors, by the way, but these do because I planned it that way. Lucky us. All right, two numbers multiply to give me 80. If I add them together, I will get 18. Now I could make a list and I could bore you to death with that whole thing, and we could be like, oh, 1 times 80 and 2 times 40 and 4 times 20, and eventually we'd get to the answer. which would be 8 times 10 or 10 times 8, depending on how you want to write it. And down here we have z plus 10. There's not a greatest common factor, so z plus 10. Now I see it and you see it, and if you want to go ahead and mark it out, you can. I'm not going to. I'm going to wait. Save that joy for later. Okay, well, let's see if there's a greatest common factor here. 2z plus 16. Oh yeah, 2 goes into 2, of course. 2 goes into 16, so z plus 8. There we go. And anything I can do down here? Yeah, no, yeah. 4 is 2 times 2. I'm going to put 4 actually, just because I feel like it. Now, on the previous problem, I was like, let's make that a 2 times 2. I kind of did it like that. Let's not do it that way this time. All right, let's start canceling some things that cancel, like that. Now, let me warn you, I put this problem in here on purpose because you might want to say z plus 8 and z plus 8. No. And the reason why not is because you can only cancel things that are factors in the numerator and denominator, like pairs, top and bottom. So those cancel. Side to side does not cancel. What I can do, though, is this. 2 over 4, you know what 2 over 4 is. 2 goes into itself 1 time. 2 goes into 4 2 times. And so I could have put 2 times 2 here. I didn't, because I didn't. So the numerator ends up being this, z plus 8 times z plus 8. And you can put that. You can put z plus 8, z plus 8. I'm not. I'm going to use exponents. That's why we have them. Z plus 8 squared. What if I don't do that? What if I put it twice? Then you're fine. And times 1. And then the denominator is 2. Now, don't reduce this. It doesn't reduce. Don't be like 2 goes into 8. No, not that. Not this one. Because this is all part of one factor. Okay. Okay, let's do one more, and this last one is a division problem. In all of these, I think the first thing we need to look for is, what are we doing? Are we multiplying or dividing? Now, later we're going to get to addition and subtraction, it's a separate lesson. And if we're dividing, we need to keep it, change it, flip it. But we'll cross that bridge if we get to it. 6y squared plus 42y over y squared plus 17y plus 70 divided by, oh look, looks like I'm going to have to keep it, change it, flip it. Okay, and I have y squared plus y minus 72. Some crazy stuff here. Y plus 10. Okay, now in the past, when I've taught this, I have done a whole bunch of stuff all at once, and it was super confusing. So if you want to skip this middle step, feel free, but I'm going to write the whole thing again, and it might be a waste of your time. So again, don't write this if you don't want to. You can skip this, but what I'm doing is writing crooked, and it's probably driving you crazy, but what I'm doing is keeping, change that to multiplication, and then flip. And if you're skipping this step and you're jumping to the next step, then you're already keeping, changing, flipping, and factoring all in one. And I'm not doing that. It's not doing overload. So this is going to become something else. And it's a fraction times a fraction. So, looking for a GCF. What goes into 6y squared plus 42y? They've been to both terms. Well, 6 goes into both terms. And both terms have a y to the first that they can give up, that they could have factored out. So 6y. And then 6y squared divided by 6y is going to give me y. Tell me why. Sorry, couldn't resist. 42y divided by 6y is 7. Okay. Denominator, GCF, no greatest common factor, but I can factor this 70. Let's see, 2 numbers multiply to give me 70. Then add together to give me 17. I'm not telling, it's your job. I'll tell you in a minute, but go ahead and do it because you know it. Nothing factors here. And then 2 numbers multiply to give me negative 72. Signs must be different. And when I add those numbers, or you could technically say when I subtract them, because the signs will be different, then I will get a positive 1. So there's a y here, and a y here, and a y here, and a y here. I hope by this point you have maybe muted me and done this one on your own. But let's see, 70, that would be 7 times 10, both positive, because nothing was negative here. But when I multiply to get a negative 72, I'm going to have opposite signs. I need a positive 1, so 9 minus 8. And then we grab the orange marker and we cancel. Let's do it. Those have canceled. Yay. those have canceled. Now I can cancel that entire thing because technically it's like y plus 10 all in parentheses. Yay. What else cancels? Well, y plus 9, not up here. Y minus 8, not up here. 6, nothing goes into 6 down here. Now, don't look at this and say, well, 6, we'll see, 3 goes into that, 3 goes into 9. Nope, that 9 is hanging around with this y. It's added, it's one quantity. And I can't reduce that y with that one or with that one. So we've reduced every factor that we can. We've canceled out all the factors that we can. So final answer, numerator is 6y. Denominator is y plus 9, y minus 8.